lesson 14 is dealing with theoretical probability, not experimental probability. Who knows the difference right off the top? Yeah, Tati?
Theoretical is like what it should be if everything is like
Perfect world, yes. And then
experimental is what would actually happen when you do it anyway.
what would actually happen if you do it? So like flipping a coin 100 times, theoretically you'll get 50 heads and 50 tails, right? But if we did that experimentally, probably it wouldn't be like that. You know, it could be way off. I mean, in you know, the odds would be really, really long, but it's possible that you could flip a coin 100 times and get heads 100 times in a row. It's not very likely at all. As a matter of fact, the exact probability of that happening is 1/2 to the 100th power. Okay, it's very, very, very slim odds, but it could happen. All right, the probability is almost zero. But so theoretical probability and experimental probability are different. Now, from time to time, you're going to run across in a problem. It's going to give you experimental data. And if they give you experimental data, then you have to use that experimental data to give your probabilities, not the theoretical probability, but the experiment. Okay? Now, I don't think there's any of those in these earlier lessons on probability. Simple probability is defined to be this. And we got a definition here. This will be on your next definition quiz. A sample space is the set of all possible outcomes of an event. Now, I ask, there will be a question on the next test, and I'm going to ask you for the sample space of an event, and people are going to miss it because they don't know this definition. The sample space is the set of all possible outcomes of an event. For example, a toss of a fair coin has two equally likely outcomes, not equally like outcomes, heads or tails. That's the sample space. So if I ask you what is the sample space for flipping a fair coin, the answer is heads, tails. That's the sample space. What's the sample space for days of the week? It's all the days of the week, right? So if we're talking about the probability of something happening on a day of a week, then our sample space is all possible outcomes. So that would be Sunday through Saturday would be the sample space. So each possible outcome is that. Karis, question? You just couldn't see me again?
No, I don't have a question.
It left.
No,
She answered it.
I remember what it was, but I don't have a question. What was it?
Okay.
It was a question. No, it doesn't. No, I don't have a question.
She doesn't have it. It's gone. Okay. Y'all leave her alone. Get off her back. Okay. Now, the simple event, a simple event is an event having only one outcome. For example, rolling a 5 on a number cube. The number cube is another way of calling something, it's a dice, right? A single die. Rolling a 5 on a number cube is a simple event. It's one outcome. Okay? Rolling an even number on a number cube is not a simple event, right? Right? Rolling an even number is not a simple event because how many even numbers are there? There's 3, 2, 4, and 6. So the sample space for rolling an even number is 2, 4, or 6. It's all the possible outcomes. Right? It's just we need to be able to speak the language if we're going to discuss this, so getting these definitions is important. A number cube labeled 1 through 6 is rolled. List the outcomes for the event. Now, what is the outcome? What is another way of asking this question? List the outcomes. What is the sample space? So what is the sample space? 1, 2, 3, 4, 5, or 6 is our sample space for this event. So all possible outcomes of the event is called the sample space. All right? a number less than or equal to 3. What's the sample space for that one? 1, 2, or 3, right? Now, here's where you got to be careful. Y'all listen. On the next test, I'm going to ask you questions like this, and somebody, usually a lot of somebodies, are going to give me the probability. Am I asking for the probability of rolling a number less than 3? I'm asking for listing the outcomes. What is the sample space for this event? So the sample space here would be 1, 2, or 3. That's the correct answer. Yes?
Like 0 or -1.
Well, a number cube doesn't generally have 0 on it. Yeah. So this is, we're rolling a dice here. It's okay, Cooper. All right? An odd number, what's the sample space? 1, 3, and 5. Any number greater than 4. Just 5 and 6, right? So can't include 4 in that. So keep in mind, and I'm going to remind you guys of this when we look at the review, we start reviewing for this test. If I'm asking for the sample space, I'm not asking for the probability, I'm asking for the outcomes. All right, so let's have a look at the definition for theoretical probability. The theoretical probability of an outcome is found by analyzing a situation in which all outcomes are equally likely. That's important. Then finding the ratio of favorable outcomes to possible outcomes. All right. So theoretical probability, let's just call that TP for short, is equal to favorable over possible. All right. So it's the number of favorable outcomes over the total number of possible outcomes. And this is not new for you guys. There's a lot of probability in Saxon before you get to this class, so you've seen this many times. Now it's important that we're analyzing a situation in which all outcomes are equally likely. If you start having weighted events, like one event's more likely to happen than another, then you have to take those things into consideration. And the probability isn't just that simple anymore. You could probably still figure it out based on this concept of favorable over possible. When you start weighting outcomes, it's different. Okay, so that's theoretical probability. All right? For example, the probability of tossing a coin and it landing on heads is 1 out of 2, or 0.5, or 50%. So that's the 3 ways that the probabilities can be listed. I would prefer this fractional standpoint, fractional representation. Okay, 50%, when you start talking about percents, you're talking about chances more so than probabilities. So I like to see probabilities as a number between 0 and 1, a fractional value. What does a 0 probability mean? It's impossible. What does a 1 mean?
It's guaranteed.
It's guaranteed. It's definite, right? So you can have those outlying things. All right, so theoretical probability formula is the number of favorable outcomes divided by the total number of outcomes. And we're going to use that to do this. This is the same thing you just wrote. Favorable over possible, right? The complement of an event, another good definition. The complement of an event is the set of all outcomes of an experience that are not in a given event. Okay? For example, if heads is the desired event when tossing a coin, tails would be the complement of that event. All right? If we're rolling a dice and we're looking for even numbers, what would the complement of that be? The odd numbers. Okay? And the probability of an event plus the probability of its complement is always going to equal 1. Which means the probability of a complement of an event is 1 minus the probability of the event. And sometimes it's easier to calculate the probability of the event and then subtract it from 1 than it is to figure out the complement. That's just the way they tell you that. So if you want to find the probability of something happening, you can always find the probability of it not happening and subtract it from 1, and vice versa. Okay? Probability of something not happening is the probability that it will happen subtracted from 1. So this little thing just kind of gives you a few more tools for taking care of finding the probabilities of an event. All right? There's 4 green, 3 blue, and 3 red marbles in a bag. Give each answer as a decimal and as a percent. So what have they given us here? What kind of information has been given?
The number of marbles in the bag.
Yeah, this is just given information, and we're going to look at some questions related to this. What's the probability of randomly choosing a red marble? 3 out of 10, right? Which as a decimal would be 0.3 as a decimal or percent, which I don't really prefer, 30%. Okay? That's pretty easy, right? What's the probability of randomly choosing a marble that is not green? 6 out of 10, right? So 6 out of 10 is 3/5, and this is one of those specific instances, guys, where not simplifying or not reducing your fraction communicates, right? 6 out of the 10 marbles are not green. We can see that from this. We don't see that as well if we reduce it to 3/5. Now, the proper thing to do is still to reduce the fraction, just because it's always the proper thing to do. But 6 over 10 communicates more to this situation than 3 out of 5 does. Yes?
Now, if we put 3/5, would you count off on that?
No, I want 3/5. I'm just saying that it's one of those instances where simplifying a fraction kind of takes away some information that's helpful. Right?
So on a test, you would want us to simplify still?
I mean, I would want you to, but I probably wouldn't count it off if you didn't in this situation. Okay? I'm not testing your ability to simplify fractions when I'm asking you a probability question. Okay? So changing it to a percent, 60%, and that's not a simplified fraction. You know, if you think about it, that's 60 over 100, 60%, 60 parts out of 100. The fraction here, or the answer here, that directly addresses the situation is this one, 6 out of 10. That's the direct representation of the situation. 6 marbles out of 10 marbles is the actual number. Okay? All right, let's have a look at another one. In a bucket, there are 10 balls numbered as follows: 1, 1, 2, 3, 4, 4, 4, 5, 6, and 6. Okay? The single ball is randomly chosen from the bucket. What is the probability of drawing a ball with a number that's greater than 4? Greater than 4. Okay, so we're looking for how many, which balls there? The number has to be 5 or 6, right? So there's these 3 out of the 10 have a number greater than 4. So that first question has an answer of 3 out of 10. This says, is there a greater chance of drawing a number greater than 4 or drawing a 1? Number greater than 4. So they're asking us to compare it, right? So 3 out of 10, what's the probability of drawing a 1? 2 out of 10. Now, the moment, y'all listen, the moment I simplify that to 1/5, I make comparing the two numbers more difficult, don't I?
Yes, sir.
It's not impossible, but what I'm trying to show you here is a scenario where when we're talking about probabilities, fractions that are unsimplified communicate better. We can compare them more readily. There's a lot of things that we can do with them. All right, so I'm trying to loosen you up a little bit like I've been trying to do with mixed numbers. I'm trying to loosen you up on fractions a little bit. Sometimes it's okay and even preferable to leave fractions unsimplified. All right. Homework. You got plenty of time, so grab a textbook and get started on this. Page 76, A through G, 1 through 17, 19 through 29.